Okay, the last part of this review is our performance test. So this one's worth a lot more than the other ones. It's 14 points total. And we have a situation of a golf challenge. So you're going to get some kind of a situation, most likely dealing with parabolas. That's why you want to make sure you really know how to work with your parabolas. So here's the situation. Mr. Reeder and Mr. Cornett are playing golf and come up to a particularly challenging hole. One choice is to play the hole safe and shoot towards the right away from the tree. The other choice is to try to hit over the tree, leaving a much shorter second shot. So what we have right here is what's called a dog leg. So one option is to shoot to the right, shooting it down like out over here. The other choice is try to shoot over the tree and you get a much shorter shot. So the tree is 240 yards down the fairway and it's 30 feet tall, which is going to be important. The tee is 2 yards above the fairway, which we have kind of shown right here. If a player uses the safe route, the length of the hole is 440. So the way they measure that, they go out like this, and then they angle it across. Now, if you cut the dog leg, and that's pretty much taking a direct route going straight to the pin, like we're trying to do, the length would only be 400 yards. So that's what we're kind of looking at, and we're going to look at both players trying to use two different strategies. So Mr. Reeder decides to play it safe and uses his 3-wood and shoots to the right of the tree. So this example here. The ball reaches its maximum height of 20 yards when it's traveled 130 yards down the fairway. That tells me my vertex is, get my pen here, 20 comma, whoops, my vertex is 130 comma 20. So x would be 130 and the y value would be 20. So this is what I'm starting with. So it's x minus 130 squared plus 20. Now I need initial point, and this is where you have to be careful. We're calling this point right here 0, 0. The point where the ball is hit is 2 yards above. So the point I'm going to plug in is 0, 2, and I'm going to need to use that a couple of times. So y equals 2 when x equals 0. Negative 130 squared, I'm going to square that. I'll subtract 20, so I get negative 18. 130 squared is 169,000, or 16,900. Then I'll divide by 16,900, reduce it, reduces to 9 over 8450, x minus 130 squared plus 20. A little bit safer equation is to leave it like this. If you did use a decimal, make sure you carry your decimal out far. Don't round it to like negative 0.001 because it's going to throw off your answers too much. So carry it out a bit further to make sure your answer stays accurate. Okay, so that was the first part. That would have been like worth 3 points. Okay, so now we're going to use this equation to answer the next part. So, using your equation for part A, how far down the fairway does Mr. Reeder's ball land? Well, it's going to land when the height equals 0. So when y equals 0, we're going to solve this equation. Now you could square this, multiply it out, try to use quadratic formula. Way hard. Make it easier. So I'm going to subtract 20. Then I'm going to multiply by the reciprocal here. So I'm going to multiply by 8450 and divide by negative 9. So that's going to make this a positive. You can do it all on your calculator. So I have 18,777.8 equals x minus 130 squared. Take the square root. Normally I would do plus or minus, but the minus won't really matter in this case. I'm just going to drop it off. Add 30. We have 267. So that tells me that Reeder's ball lands 267 yards down the fairway. So I just went through the steps, finding out where it lands. I got to know when y equals 0. And then I'm just going to go through and solve, taking advantage. You use your calculator for this kind of a problem. Now, Mr. Cornett is going to try to hit the ball over the tree. He used a 5-wood to get the ball higher. His ball reaches a maximum height of 40 yards when it's traveled 126 yards down the fairway. So his vertex is 126, comma 40. So again, I'm going to do the same kinds of steps we did when we solved for Reader's equation. Now the A in this case is again going to be 2. We're going to find the A. We're going to use the point 0, comma 2. So I subtract 40, I get negative 38, square 126, you get 15,876, divide it, and if I reduce it, I have this equation here. And again, if you want to use the decimal, then you would have this one. But make sure, again, you carry it out far enough so that you don't have a rounding error. Okay, so now we're going to use this information to do the big part of the problem. We're going to decide who used the better strategy. Was it a good idea for Mr. Knuett to try to hit it over the tree and get it down the fairway? How does it compare? So, last part of it. Who used the better strategy? Well, if we look at Mr. Reader's equation, he has negative 9 over 8450 x minus 130 squared plus 20. We don't have to worry about the tree, so we just simply know that his ball lands 266 yards down the fairway. That leaves him another 173 yards to go. Now, it may be less, it could be more, because remember, when you shoot it down the fairway, when he takes his shot, he's going to shoot it down to here. If it goes too far, it bounces out, it may be even in a worse situation. So it's a possibility there are even issues there. But we're assuming he's going to be safe right here. That's probably going to be the case. Now, Knuett's equation was this one. Now, I could do the same thing and solve this, find out when it equals 0, and work with this. But my big concern isn't about that, but it is this tree. Because he tried to shoot over the tree. Well, that tree is 240 yards down the fairway. So I'm going to plug in 240 into this equation. Just type that into your calculator, and you find that the y value is 8.893, but units are in yards. The tree is 30 feet tall. Well, in feet, the ball's height when it gets to the tree is 26.7 feet. That is not as tall as the tree. So Mr. Knuett's ball is going to hit the tree. So Knuett's ball hits the tree, therefore, he may not even get a shot. He can get something where it bounces the tree, it may be sitting right behind it, he may not have a shot at all. Now, so most likely Reader's going to be better off. He would have used a better strategy. Now, Knuett could get lucky, and the ball bounces a little bit loose, and maybe it stops after going 240 yards. And then he would only have then, since his distance is only 400 yards, he'd have 160 yards left, so he could potentially be closer. So again, with this kind of a problem, you don't necessarily have a right answer, but you have to support the answer that you have, and with reasons, and be able to make sure you approach the correct items. So you can't just simply go over, you try to solve this equation and you let y equals 0 and figure out how far did Mr. Knuett's ball go, and then use that to figure out your answer. You'd get some partial credit, but you're going to be losing out, and one of the main things is watching out for some of the obstacles that may be coming in. Okay, that completes the review for our free response test.